Good morning to all. Myself Vimala, I am working assistant professor in the Department of Electronics and Communication Engineering, P.S.R Engineering College. Today I am going to take the topic as network reduction. In that network reduction, particularly we are going to see a Thevenin's theorem. Before enter into the topic, we first understand why Thevenin's theorem is needed. It often happens particular element in a circuit is fixed while other elements are variable. The variable elements can be changed every time. At that, the entire circuit has to be analyzed again. So that avoiding this problem, Thevenin's theorem provides a technique. That technique includes the fixed element can be replaced as an equivalent circuit. That equivalent circuit consisting of only two elements. First one is the VTH, that is the voltage source, and then another one is the resistance, that is RTH. These two elements can be included in an equivalent circuit. So, first we will see the statement of the Thevenin's theorem. Okay. This is the statement, that is any network, linear and bidirectional network which is having a two terminal that can be replaced by an equivalent network consisting of an voltage source VTH connected in series with resistance RTH. So, this VTH is the Thevenin voltage and this RTH is the Thevenin resistance. While replacing the fixed element, we are drawing a one equivalent circuit. That one equivalent circuit consisting of two elements, VTH is series with RTH. Okay. So, this is an arrangement I can draw. This arrangement containing a network, any network, linear network or bidirectional network which is having a two terminal that will be connected to a variable load. Okay. So, this one is a fixed one and this one is a variable one. Okay. So, this variable one can be changed at every time. At that time, the entire circuit has to be analyzed again. Okay. While replacing this problem, we are introducing a fixed circuit can be replaced as an equivalent circuit. So, this is the equivalent circuit diagram which contains VTH and RTH are connected in series, which is connected across the load resistance. Okay. So, this is the equivalent circuit diagram for the Thevenin's theorem. Before enter into the problem, first we will discuss about the steps. So, these are the steps while solving the electrical networking by using a Thevenin's theorem. The first step is to identify the load terminals. In a circuit, they are having a load terminals that will be first identified. And second one is the remove that load resistance. Okay, that corresponding load resistance can be removed by in the step 2. And step 3, find the equivalent resistance. That is, equivalent resistance is nothing but a Thevenin resistance. Okay, by finding the equivalent resistance by using the method of, in case in our circuit we are having a voltage source, means that will be short circuited. If circuit we are having a current source, means that will be an open circuited. Okay. After that, finding an RTH, again you have to find the value for the open circuit voltage by using the methods of any method. KVL method, KCL method, mesh analysis method or nodal analysis method. We know that KVL means that is a Kirchhoff voltage law, Kirchhoff current law, mesh analysis or nodal analysis. By using this any method, you can find out the open circuit voltage. And fifth step is the draw the Thevenin equivalent circuit, which is already drawn here. This is an Thevenin equivalent circuit diagram. Now we will see one example problem for Thevenin's theorem. So, this is the problem. The circuit having a voltage source, that is 12 volt, and then one current source, that is 2 amps. Okay. So, this is the load resistance, this is a variable load resistance. That value is given as 2 ohm. Okay. So, we already saw the steps for Thevenin's theorem solving problem. Okay. First step is to identify the load resistance value. Okay. In this circuit, the load resistance value they are mentioned RL value which is equal to 2 ohm. So, this is the load resistance value we already identified. Okay. And step 2, what is the step 2? To remove the load resistance. Okay. So, to remove the load resistance, you can redraw the circuit. And remove the load resistance and labeled as A and B. Okay. So, next step is the third step, to find out the value for RTH value. Okay. So, that is find RTH value, that is Thevenin resistance value. Okay. So, while finding the RTH value, if we are having the circuit, having the voltage means that will be short circuited. Okay. So, voltage, that is voltage source will be a short circuited, whereas in current source that will be an open circuited. Okay. So, in our circuit we are having a voltage source as well as the current source. So, this voltage source can be short circuited and this current source will be a open circuited. So, this will be shorted and this will be as open circuited. Okay. And this is the 6 ohm resistance, again here is also 6 ohm resistance and this is 4 ohm resistance. When, while open circuited, these two resistance are in series combination. So, at that time what we get, that is 6 plus 6 which is equal to 12 ohm. Okay. You can redraw the circuit, that is 12 ohm resistance which is parallel with 4 ohm. Okay. So, you can redraw this. These two resistance are in series combination. You can combine here as a single resistance and this is a 4 ohm resistance. Now, these two resistance are in parallel combination. So, 12 is parallel to 4. What we get? So, 12 into 4 divided by 12 plus 4, you can get 3 ohm. So, this is the RTH value. Okay. So, next step is to find out the value for Thevenin voltage. So, find Thevenin voltage, that is VTH value. Okay. So, this can be find out by using the method of any method, mesh analysis method, nodal analysis method. In our circuit having only an voltage source means you can go for the mesh analysis. In circuit we are having a current means you can go for the nodal analysis. But in our circuit we are having a current source. So, that we are go for the nodal analysis method. Nodal analysis method means at each and every node we are indicating a node value. Okay. So, this is I am indicating here as V1 and this is I am indicating here as V2. Okay. Now, I am applying node analysis to the node V1. First node V1 I am applying the nodal analysis. So, nodal analysis means which is similar to the Kirchhoff current law. Okay. So, we know that Kirchhoff current law means incoming current which is equal to outgoing current. The same method is applied here. So, this is the 12 volt. So, 12 volt minus V1 divided by resistance value is 6 plus and the next incoming current is 2 amps. So, next 2 amps which is equal to this is incoming current, this is incoming current, here as an outgoing current. Okay. So, you can taken as V1 minus V2 divided by 6. Okay. So, here we are applying the nodal analysis. Here we are applying nodal analysis at this particular node V1. Incoming current is this way, this 12 volt here as incoming and this 2 amps is incoming and this is an outgoing. Okay. So, incoming current which is equal to outgoing current. So, 12 volt minus V1 divided by resistance 6. Okay. Next 2 is the incoming current. So, 2 amps which is equal to this is the outgoing current. So, V1 minus V2 divided by 6. While solving this equation, V1 which is equal to 24 plus V2 divided by 2. Okay. So, next similarly you can apply the nodal analysis to the node V2. Okay. So, at node V2, this is V2 node, this one is incoming current, this is outgoing current. So, V1 minus V2 divided by 6 which is equal to V2 divided by 4. Okay. So, while solving this equation, 4 V1 minus V2 which is 6 into V2. Next 4 2 V1 minus 2 V2 which is equal to 3 V2. So, 2 V1 minus 2 V2 minus 3 V2 which is equal to 0. 2 V1 minus 5 V2 which is equal to 0. So, already okay. So, next here already we simplified the equation V1 which is equal to 24 plus V2 divided by 2. So, substituting here 2 into 24 plus V2 divided by 2 minus 5 V2 which is equal to 0. Okay. So, while simplifying this equation you will get V2 value, that V2 value is V2 value is 6 volt. Okay. So, this is the Thevenin voltage. So, V2 which is equal to VTH which is equal to 6 volt. So, next step is the draw the equivalent circuit diagram. So, equivalent circuit diagram means VTH, that value is 6 volt, and then series is resistance, that is RTH, that RTH value is 3 ohm, and connected across the load resistance, that load resistance value is that load resistance value is RL which is equal to 2 ohm. Okay. So, in this circuit we will find the current value. Okay. So, we know that current which is equal to voltage divided by resistance. So, I which is equal to, so in this circuit we will find the current value, that is I which is equal to V divided by R. So, I which is equal to VTH divided by resistance. This resistance, two resistance are in series combination. So, RTH plus RL. So, substitute the value, VTH value is 6 volt divided by RTH value is 3 plus RL value is 2. Okay. So, we will get the value as 1.2 amps. Thank you.